Now we are coming to the most important group of compounds among the organic nitrogenous compound, namely the amines. We have discussed earlier some of the important reactions of amines, and one of the important reactions of amines is the reaction of an aromatic primary amine with an aldehyde or a carbonyl compound. It is not necessary it should be an aldehyde, it can be either a ketone also. So primary amines react with is an aromatic primary amine. This reacts with an aldehyde like benzaldehyde to give rise to a compound like this. A compound is known as this NH, N double bond CH. We have this. This is known as a Schiff's base. This is known as a Schiff's base, or sometimes is also called as an anil. What we have here is the loss of a molecule of water from this H2O to give rise to what is known as, and this is what is referred as N double bond CH is known as an imine linkage. This is referred as an imine linkage. An imine is being formed from an amine, a primary amine. It reacts with benzaldehyde or with any other, even a carbonyl compound. As a typical example, I have taken as a benzaldehyde, and then to give rise to a compound known as an imine or a Schiff's base. This reaction is very important because this Schiff's base, this double bond NCH of the imine can be reduced by means of hydrogen, some source of hydrogen, hydrogen palladium or something like that, can give rise to a secondary amine. This will give rise to, this N will become NH, this CH will become CH2, and then the phenyl group will remain there as it is. So this is one of the methods of preparation of a secondary amine. This can be called as reductive amination. That is, imine is being produced, imine that is being reduced to give rise to an amine. Therefore, this can be called as reductive amination. So this is one of the important reactions, formation of Schiff's bases. Supposing we make use of instead of benzaldehyde, we make use of a carbonyl compound like say benzophenone. Then you don't have this, you have this one more phenyl group being given here. Or supposing it is acetophenone, this will be a CH3 instead of H here, but still the imine linkage, the N double bond C will be present, which suitably can be reduced with hydrogen to give rise to this. That is the importance of this particular reaction, the imine formation. The imines also, once the imines are formed, the imines can go back to the amine and the aldehyde by means of hydrolysis. On boiling with HCl or something like that, the imine linkage breaks to give rise to, give back this, this part will become the amine, primary amine, and this part will become the aldehyde. So that is the importance of this particular reaction. So that is actually the second question. Another third question is, this is a very simple but a very interesting question in the sense, when you look at this compound, this is actually para-nitro-cinnamaldehyde. The name of the compound is para-nitro or 4-nitro-cinnamaldehyde. This is cinnamaldehyde, this is as it is cinnamaldehyde, we have a nitro group in the 4th position, so this is referred as para-nitro-cinnamaldehyde. What will happen when this para-nitro-cinnamaldehyde is reduced by means of stannous chloride and HCl under mildly heating conditions? When it is reflexed with stannous chloride and HCl, this, as we know immediately, it is a reductive condition, that is, it is a good reducing agent. Stannous chloride is one of the very good reducing agents. In acid conditions, this reduces. But the most interesting part of this question is, this has 3 reducible functions. One is the nitro group here, another is the olefinic double bond, and the third one is the only thing is the ring is not affected. The aldehyde group can be reduced. The aldehyde group is something which can get oxidized to the acid or it can get reduced to the alcohol. So aldehyde group will get reduced to primary alcohol. This may get reduced to some saturation function, CH2, and this can get reduced easily to a variety of compounds depending on conditions. Preferably in HCl condition with stannous chloride, this may give rise to NH2. But the most interesting aspect of this question is, nothing of this is being affected. The double bond is not affected, the CHO is not affected. Only thing is the NO2 is being reduced to NH2. So what is the product that is obtained? This NH2 will be there. Then we have the ring which is not affected, which is going to be there, and then all the other things will remain the same. So you find that this is a very highly selective reduction. This is not being influenced by means of this. This is not being influenced by means of this. Only this nitro group will get reduced to the amino group. That is the importance of this question. So there is, it speaks of the selectivity of the reducing agent. In fact, we have a number of reducing agents like hydrogen and palladium, and acid and HCl will liberate hydrogen, or various other hydrogenation over nickel as a catalyst, hydrogenation over nickel, or hydrogenation over palladium, or hydrogenation over palladium over barium carbonate, or calcium carbonate, or barium sulfate support. There are different types of reducing agent. Each one has got a selectivity, and this particular reducing agent does not affect any of these things excepting the nitro group. That idea is being conveyed by means of this type of question. And the first one relates to the formation of the fifth base.